Hi, this is Darshan Senthil and welcome to our series on derivatives. So in this video, we're just going to be talking about lots and lots of rules of differentiation. Okay, so let's go ahead and get started then. So the derivative of a sum or a difference of two functions is basically the derivative of each function and then added or subtracted together. So basically, this is going to be as follows. So the derivative of f of x plus or minus g of x is going to be d dx of f of x plus d dx of g of x. Okay? Now, if we have a constant, c can be any constant, we can pull it out front of our derivative, so we don't actually, so we can bring it out like this. So this basically means that we will have c times the derivative of f of x. So yeah, these are pretty basic rules, not that hard. They're very similar to the ones you might have learned in limits, and these will also be similar to what you will eventually learn when you study integrals. So that's just some handy knowledge to keep in mind. Now, these are the ones that really are going to require your focus and your concentration, because I'm going to tell you the rules, but I'm also going to help you sort of memorize them. You're going to have to memorize them eventually. It's just something math teachers love to give you, but I'm going to also give you some tips and suggestions for how you can sort of make memorizing this a lot easier. Okay, so with that in mind, let's get started. Let's do these in red. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. That can easily mess a lot of people up. Be careful. The derivative of tangent of x is secant squared of x. The derivative of e to the x is very convenient, it's just e to the x. The derivative of the natural log of x is 1 over x. Cosecant of x, you will have negative cosecant of x times cotangent of x. The derivative of secant of x is going to be secant of x tangent of x. The derivative of cotangent of x is going to be negative cosecant squared of x. The derivative of a to the x is going to be a to the x times the natural log of a. Now the derivative of the log of a, log base a of x, is going to be 1 over x times the natural log of a. Okay, so those are your rules. So I know you might be a little scared now, but I'm just going to give you some suggestions and some tips here that'll really help you memorize. Okay, so number one, take a look. Notice that cosine, cosecant, and cotangent are all negative. Notice that they're all negative. So the rule of thumbs that I like to use is that whenever you have a c, that's going to equal, you're going to have a negative. Okay, so even if you don't know what the derivative is, you know it's going to be negative. So whether it's cosine, cotangent, cosecant, you're going to have negative. So that's just a really interesting thing I found, and it's pretty helpful information as well. The next thing you want to notice is you want to notice the correlation between similar functions. So for example, look at the derivatives of sine and cosine. They're pretty similar. Same thing goes for cosecant and secant. Also pretty similar. Same thing goes for cotangent and tangent. Also pretty similar. Like you see this cosecant squared, that's secant squared. Same thing goes, so for these four, there's also some very interesting correlations here I'm going to talk about. So actually, if you really think about it, these two are special cases of those two. These two are special cases of those two. So consider this. If you plugged in for both of these, let a equal e. Let's see what happens. So this would be e to the x times the natural log of e. That would be 1 over x times the natural log of e. In both of these cases, the natural log of e is just 1, so that will go. Same over here, so you're just left with 1 over x and e to the x. So as you can see, there's some pretty interesting correlations here. So you can use those to your advantage too. So if you know this one, but you forget what the derivative of e to the x is, you can just say, okay, let's plug in e, and then you'll get that answer out. So that's just some handy information for you to have over there. Okay, so that's that with those rules. Now let's move on to a few more rules. So these are a little bit more complicating. So the derivative of the inverse sine is going to be 1 over square root of 1 minus x squared. Of inverse cosine, we're going to have, except it's going to be negative. Tangent, we're going to have, so you could also see 1 plus x squared, but it's really the same thing. For cosecant, you're going to have, this one is the hardest to remember, honestly, just because it's so intimidating. Absolute value of x times the square root of x squared minus 1. That's pretty intimidating. Then 1 over the absolute value of x times square root of x squared minus 1, except that one's negative. Cotangent, same again, 1 over 1 plus x squared, except that one's also negative. Okay, so again, the same correlations apply. So as you can see again, similar functions, cosine and sine, very similar derivatives. Cosecant and secant, very similar derivatives. Tangent and cotangent, very similar derivatives. Again, the c equals, the negative c is also true. So if you have a c, it's going to be negative. Same thing is true here. Cosecant, cotangent, cosine, all are negative. So again, those correlations still hold true. Now we're going to end this video with just a couple of examples, and then we'll be done. So let's move on. So 3 times 6 cosine of x plus 2 sine of x. So not too hard an example. It's just to test whether you've got all the rules. And again, so first thing we're going to do is we're just going to keep that 3 out there. Again, because we know that we can factor out coefficients. So we're just going to keep the 3 out of there. Then we're going to... Now notice again we have a 6 here. So again, we can also factor out that 6. So we're going to make that 6 cosine of x plus, again, another 2 we can factor out. Now all we have to do is take the derivative. So d dx. So the 3 stays as it is. The 6 stays as it is. But what's the derivative of cosine? Well, that's going to be negative sine, right? Because cosine has a c. Plus 2 times the sine of x, that's just going to be cosine. And again, I'm just going through these quickly for the sake of time, but feel free to slow it to go back in the video as you desire. And again, just some simplification. So that would be d dx. Actually, I'm going to say dy dx because that would be bad notation otherwise. That's going to be, so that would be 18, negative 18 sine of x. Yeah, the 3 is also distributed there, so plus 6 cosine of x. That's number 1. Let's do this one in black. So 3 to the x, that's just rote memorization, so that would be 3 to the x times natural log of 3. Now here it might look a little scary, so it's very helpful to factor out the 1/3 first. So I'm going to do this up here just so that I don't have to do it again. So this would be 1/3 times the natural log of x. So I'm just going to say 1/3, what's 1 over x? What's the derivative of natural log of x? That's just 1 over x. So that would leave me with 3 to the, oops, not 3x, it's 3 to the x. Whole different thing. So it'll be 3 to the x, natural log of 3, plus 1 over 3x. This was a pretty straightforward one. And again, remember, the reason we can do the derivative of each of these terms is because of the sum and difference rule, because we're allowed to take the derivative of each term. All right, e to the x secant of x. Let's do this one in blue. So the derivative of e to the x. Oh yeah, by the way, quick side note, I should be writing dy dx here. That's otherwise I'd be lying. So dy dx equals e to the x sine of x, secant of x, which is going to be e to the x. The derivative of e to the x is just e to the x, minus secant of x, that's going to be secant of x tangent of x. Notice we're not going to make it negative again because there's no c. So those would be our answers. So thank you so much for joining me in this video. I hope you learned as much. I hope you learned a fair bit. And yeah, please do feel free to comment, like the video, share, subscribe. Please do comment, give me some constructive feedback on how I'm doing. Again, I want to make my work as good as I possibly can. So thank you for watching once again, and have a great day.